Have you ever been on a website like looking for a really specific product and you just get completely overwhelmed by their messy menu and you just leave?
Oh, yeah. All the time.
Right. You click on a category that sounds promising
Mm.
and it leads to a dead end. Or you try the search bar and it gives you completely irrelevant results, like accessories instead of the main item you actually want.
Yeah, and you just give up and go to a competitor.
Exactly, just bounce. And that frustration, I mean, it isn't just an annoyance for you. It's what industry experts call the invisible cost of disorder. And it is quietly bleeding millions of dollars from businesses every single year.
It really is a massive financial leak. And the tragedy here is that most companies, they don't even realize they have it.
They just don't see it.
Right. They look at their dropping sales and they blame, their marketing team or they blame their pricing strategy. But the reality is actually much more foundational. It's a structural information problem.
And so, okay, that is our mission for this deep dive. We are going to simplify the honestly surprisingly fascinating relationship between information architecture, meaning like how data is structured, and SEO.
Yeah, specifically for anyone who is just, starting to look at this field.
Right. It's a journey into how organizing information doesn't just make a website look pretty.
Hmm.
It actually increases your sales, it reduces the mental strain on your customers, and it stops those massive financial leaks dead in their tracks.
Absolutely. And to guide us through this, we're pulling from a really deeply insightful article by SEO specialist and information scientist Alexander Rodriguez Silva.
Published on the blog Semantico, right?
Yes, exactly, on the blog Semantico.
Uh-huh.
And he brings this really unique perspective, kind of bridging the gap between old school library science, modern user experience, and, search engine optimization.
Okay, so let's unpack the core problem first.
Yeah.
Like, why is a messy website so incredibly destructive? Not just to us as human shoppers, but to modern search engines.
Right.
Because before we can fix a disorganized website, we really need to understand the mechanics of why bad organization causes businesses to lose so much money.
Right. It comes down to where information architecture actually operates. It sits at the exact intersection of human cognition and the increasingly intricate data infrastructure of the web.
Okay.
So when data isn't in a logical structure, two critical things fail at the exact same time. First, humans experience a highly elevated cognitive load.
Cognitive load, which just means your brain has to work way too hard to find answers, right?
Exactly. If it takes too much mental energy to navigate a menu, you just abandon the task. You leave.
Yeah. Nobody has the patience for that.
Nobody. And second, and this is just as important, natural language processing algorithms, the bots trying to index the site, they fail to understand the meaning of your content.
I always try to visualize this like a massive, completely chaotic physical supermarket.
Oh, that's a good way to look at it.
Yeah, like imagine you walk into a grocery store, but there is no logical layout whatsoever. The milk is sitting on the shelf next to the motor oil simply because, I don't know, they're both liquids sold in plastic jugs.
Right, just grouped by physical shape.
Exactly. And the signs above the aisles are written in a completely made-up language. If you can't find the milk within a few minutes, you aren't going to wander the aisles for an hour. You just leave the store.
Yeah, that is the perfect visualization of what happens digitally. But, the digital version is actually worse.
Really? How so?
Because it's not just the human shopper who leaves, it's the search engine itself. If Google's algorithm, specifically models like BERT, if it enters that chaotic digital supermarket, it relies entirely on structure to understand context.
Wait. Before we go further, if someone listening is new to SEO, they might hear BERT and just think of Sesame Street.
Right, yeah, naturally.
Can you give us a quick, plain English breakdown of what that model actually is?
Of course. So BERT is a major update to Google's search algorithm that focuses heavily on natural language processing.
Okay.
Instead of just reading a sentence word by word from left to right, like older models did, BERT reads in both directions at once.
Oh, wow. Both ways.
Yeah, it looks at the words that come before and after a specific keyword to understand the full context and intent of a search.
That's smart.
It is, but here is the catch. BERT needs clear entities and categories to do that effectively. If that enters your chaotic digital supermarket and it can't figure out what entity a page actually represents because the categorization is just a mess,
Then what happens?
that page essentially becomes invisible. It loses all its organic visibility.
It's just gone from the search results. Because the algorithm couldn't confidently figure out if you were selling milk or motor oil.
Exactly. And what's fascinating here is that this failure is completely avoidable.
Because of how our brains work.
Right. The human brain is the ultimate categorizing machine. Categorization is what fundamentally separates an intuitive, enriching user journey from absolute informational chaos.
Yeah, we are constantly grouping entities by similarity and like meticulously separating them by their differences. We do it without even thinking about it.
We're hardwired for it.
So, okay, if categorization is the ultimate cure for this digital chaos, how do we actually do it systematically? I mean, let me play devil's advocate for a second here.
Go for it.
Organizing a digital store sounds like common sense, right? You put the shirts with the shirts, the pants with the pants. Do we really need a whole scientific framework for something so basic?
We absolutely do. Because digital scale kind of shatters common sense.
What do you mean by that?
Well, when you have a catalog of tens of thousands of items, shirts with shirts isn't nearly enough anymore. What happens when a user wants a blue cotton shirt for summer that costs under $50?
Oh, right. You need a lot more detail.
Exactly. And that is why the author introduces us to the NISO Z39.19 guidelines.
Wow. Okay, that sounds like a serial number for a spaceship.
I know. It's an intimidating name for a very practical standard. It was originally developed for constructing controlled vocabularies and taxonomies, like library science and complex knowledge systems.
But it applies to e-commerce.
It applies flawlessly to modern e-commerce. Structuring an optimized database requires absolute precision to enable things like multidimensional faceted search.
Okay, let's translate that. Multi-dimensional faceted search. You mean those incredibly handy sidebar filters on shopping sites?
Yeah, exactly those.
Where you can check a box for blue, then a box for under $50, then cotton, and the results update instantly.
Yes, those exact filters. If you want those filters to actually work and not accidentally show a user a blue plastic toy when they ask for a blue cotton shirt, you need a flawless underlying structure.
Okay, that makes sense.
And based on those NISO guidelines, the author outlines 7 essential concepts that you need to organize any product catalog.
Okay, let's test this out. Instead of just listing these 7 concepts like a textbook, let's build a scenario.
I like it. Let's do it.
Say I am building an e-commerce site that sells high-end tech, and I want to list a new gaming laptop. How do these 7 concepts actually build my search filters?
Okay, so we start with the physical reality of the object. The database first needs to know the thing.
The thing.
Right. This refers to the tangible object itself.
Mm.
In this case, the thing is a notebook computer.
Got it.
Next, the database needs to know the material. What is the thing made of?
Yeah.
For your premium laptop, the material might be an aluminum chassis or a glass trackpad.
So we've established what the physical object is and what it's built from, but like a laptop is defined by what's inside it, right?
Exactly.
The screen size, the memory, the battery life. How does a database handle those details?
Those details fall under properties. These are the inherent characteristics or states of the object. So a 15-inch screen or a primary color of matte black or 32 gigabytes of RAM.
Wait, but notice how you just used a specific measurement there?
Good catch. That brings us to the next concept, which is measures.
Ah, so the gigabyte itself needs its own category.
It does. Measures are the units of scale or quantity. Centimeters, gigabytes, volts, or even the financial currency it's sold in.
Because if you don't separate the measure from the property?
The algorithm can't effectively let a user slide a scale to filter between 16 and 32 gigabytes. It just sees a chunk of text.
Okay, so our database now understands we have an aluminum notebook computer measuring 15 inches with 32 gigabytes of memory. But earlier I said it was a gaming laptop.
Right.
Gaming isn't a physical part of the computer, it's an action. So how do we categorize that?
That requires the activities concept.
Mm.
Activities represent processes, actions, or user interactions. In your store, you categorize the laptop by what the user actually does with it: gaming, video editing, or 3D rendering.
Okay, so activities. What's next?
Along with activities, you also map the disciplines. This refers to broad areas of study or overarching branches of knowledge.
So a high-end laptop might belong to the discipline of software engineering or digital art. That leaves one last piece of the puzzle. What if I want to put this laptop on a huge discount for Black Friday?
That is handled by events. These are occurrences situated in time. Black Friday, a summer tech sale, or a specific back-to-school campaign.
Okay, so let me get this straight. When you combine all 7 of these concepts, things, materials, properties, measures, activities, disciplines, and events.
You aren't just slapping a text tag on a product anymore. You are building a rigorous, multidimensional matrix for your data.
Yeah, if you are listening to this right now and you work with a dev team, handing them these exact 7 concepts is your blueprint for success.
Truly.
Instead of just vaguely asking them to make the site searchable, you are giving them the exact data architecture they need to build a cutting-edge recommendation engine. You eliminate all the ambiguity.
And eliminating ambiguity is crucial because it leads to our next major hurdle.
Hmm.
We've meticulously tagged our data with these 7 text-based concepts, but algorithms don't read English.
Right. They don't intuitively know what aluminum is or what a laptop is.
Exactly.
Which brings up a massive question. How do the search algorithms actually group these items together if they just see raw data?
They rely entirely on math.
Math, of course.
Yep. To understand how they sort everything, we have to look at how they calculate similarity and dissimilarity. The author makes the critical distinction here between structural similarity and semantic similarity.
What's the difference?
Well, structural similarity is just looking at the physical occurrence of elements, like 2 articles that happen to use the same keywords over and over. But semantic similarity focuses purely on meaning.
Meaning. So it's when 2 documents discuss the exact same concept, even if they use completely different words.
Exactly.
So if I'm listening right now, I might be thinking, okay, great, but how does an algorithm do math on meaning? Like, how does a word become a calculation?
It uses a mathematical framework called a vector space model. The system takes every document, every product, and every text tag you've created and converts them into vectors.
Vectors.
Right. A vector is essentially a line with a specific direction and magnitude in a multidimensional space.
Okay, if you haven't taken a geometry class in a decade, don't panic. Let's try to visualize this.
Good idea.
Imagine plotting words on a massive, invisible 3D graph in the air right in front of you. Words that mean similar things live in the exact same neighborhood on this graph.
Yes.
So the word dog and the word puppy are plotted very close to each other, but dog and spaceship are plotted very far apart.
That is the perfect mental model. And the algorithm measures how closely related 2 things are using a metric called cosine similarity.
Cosine similarity.
Right. It literally calculates the angle between those 2 vectors on your 3D graph. The smaller the angle, the closer the vectors are to pointing in the exact same direction.
Meaning the more semantically similar the items are.
Exactly.
That is wild. That's how AI models understand context without having a human brain. It is literally just calculating the angles between concepts.
It is entirely geometric. But, just as important as finding similarity is calculating dissimilarity.
Really? Why?
Because you can't just group things together, you must also mathematically separate them.
But wait, why is separation just as important? If I search for a product, wouldn't I want the search engine to give me everything that is highly similar?
Think about what happens if you search for a product and the search engine gives you 10 results that are identical clones of the exact same item.
Oh, yeah, that would be useless.
It's redundant and incredibly frustrating.
Yeah.
So dissimilarity, which mathematically is often calculated as Euclidean distance.
Which is essentially just the physical distance between points on your graph.
Exactly. It's vital because it prevents that redundancy.
Yeah.
It ensures diversity in your search results. And it also helps the system identify outliers, which is information that just doesn't fit the established pattern.
So the cosine similarity clusters things together to form a solid category, and the Euclidean distance ensures you aren't just looking at 10 identical clones of the same product.
Right. And the author highlights a really profound philosophical insight here regarding that balance.
Oh.
In information science, nothing is ever truly equal. Total identicality is incredibly rare.
That's interesting.
Yeah, things are only ever highly similar. We are always working with degrees of approximation. And that specific degree of approximation is what defines the relevance of a search result.
Nothing is identical, just highly similar. I love that. Okay, the math class is officially over. Let's talk about real-world sales psychology.
Let's do it.
We have covered the science, and we understand the vector math. But how does this abstract geometry actually look in a real e-commerce scenario? And most importantly, how does it directly increase a company's revenue?
So, to connect the math to the money, we have to look at how a product is defined by 2 completely different viewpoints. What the object is versus how the object is used.
The intrinsic view versus the extrinsic view.
Exactly.
Now, here's where it gets really interesting. The author uses a brilliant example for this to make it tangible. A highly sought-after Stanley thermos. Let's break down those 2 distinct views.
Okay, so the intrinsic view is the ontology of the object. It's the cold, hard reality of what it physically is, regardless of who buys it or why they buy it. So, intrinsically, the Stanley thermos is made of stainless steel. It features vacuum insulation. It holds 500 milliliters of liquid.
Right. So if we are organizing our website strictly by the intrinsic view, we would group it under a logical path like kitchen, then containers, then thermoses, which makes perfect sense to a database.
It makes perfect sense to a database, but humans do not shop like databases.
No, we don't.
And that brings us to the extrinsic view. This is all about the perception and the application by the user. Here, we actually ignore the physical reality of the objects and group them entirely by functional context.
Okay, let's paint a picture of two different shoppers looking at that exact same Stanley thermos to see how this plays out.
Okay?
Scenario A, we have a hardcore camping enthusiast.
Right, so for the camping enthusiast, the extrinsic context is outdoor survival and comfort. In their mind, that thermos belongs grouped together with heavy-duty tents, zero-degree sleeping bags, and tactical flashlights.
But a thermos does not look like a tent. Intrinsically, they share zero physical properties.
Zero. But extrinsically, they serve the exact same user journey.
Wow. Now consider scenario B, the corporate office worker.
The office worker isn't surviving in the woods. They're trying to survive a marathon of Monday morning meetings.
True.
For them, that exact same thermos is a productivity tool, and honestly, a status accessory. Extrinsically, it should be grouped with daily planners, leather desk organizers, and ergonomic computer mice.
The sales psychology there is just brilliant. The author explicitly states a rule that every marketer should write down. Extrinsic similarity generates the desire. Intrinsic similarity validates the technical purchase.
That is the golden rule of e-commerce architecture right there.
Think about it. If I am looking for a Father's Day gift for my outdoorsy dad, and the website forces me to navigate through kitchen, then containers, then stainless steel, then 500 milliliter...
They're gone.
I'm going to leave the site. I want to click a category called Gifts for the Adventurer and see the thermos sitting right next to the compass. The extrinsic category makes me want to buy it. Then I check the intrinsic details like the stainless steel, the 500 milliliter capacity, just to justify the purchase in my head.
Exactly. And if we connect this to the bigger picture, if a company fails to map this extrinsic context, they create massive algorithmic noise. The author warns that an e-commerce site without a clear distinction between what a product is and what it represents isn't actually a strategic sales tool.
What is it then?
It's just a digital warehouse.
A digital warehouse.
Yeah.
That perfectly describes the frustration we talked about at the very beginning of this deep dive.
Yep.
These companies just dump their inventory online, slap intrinsic tags on them, and expect the user to sort it out.
And when you force users into exhaustive manual filtering to find what they desire, your bounce rate skyrockets and your conversions plummet. You are relying entirely on the user's sheer willpower to find the product, rather than guiding them naturally by reducing their cognitive load.
Okay, so let's say a business listens to this. They flawlessly map their architecture using the 7 NISO concepts. They balance the intrinsic physical facts with the extrinsic human desires.
Okay, best case scenario.
Yeah. How do they make sure Google actually knows they've done this work? How do they prove to the search engine that they are the ultimate domain authority?
That requires the final piece of the puzzle, entity extraction. This is a foundational pillar of semantic SEO.
Entity extraction.
Right. We talked earlier about natural language processing, or NLP, and algorithms like BERT. When search engines crawl the written content on your site, like your blog posts, your buying guides, or your product descriptions, they use NLP to identify specific entities within your text.
What kind of entities?
They are looking for people, places, organizations, and abstract concepts.
So they're essentially scanning the paragraphs and pulling out the most important nouns and relationships to figure out what the page is truly about.
Yes. And the goal of semantic SEO is to ensure that the entities the algorithm extracts from your articles perfectly align with the taxonomy and the 7 NISO concepts you've built into your site's back-end architecture.
Ah, okay. Give me an example of how those two things connect.
Let's say you write a blog post titled Top 10 Essentials for Winter Camping. Within that text, the NLP algorithm extracts entities like outdoor survival, heat retention, and Stanley thermos.
Okay, I follow.
Because your site architecture already extrinsically links the thermos to camping gear, the blog post reinforces the database structure. You consolidate your semantic domain. You are mathematically proving to the search engine that your content is a highly reliable authority in that specific field of knowledge.
You know, it's worth pointing out that semantic SEO is not just some new fad that popped up when AI became the ultimate corporate buzzword.
Not at all.
Information scientists have been using NLP and entity extraction for years. It has always been about proving semantic dominance to the search engine by feeding it a perfectly structured meal of data.
It is about speaking the algorithm's mathematical language flawlessly, which, paradoxically, requires a deep empathetic understanding of human psychology and desire.
That's a great way to put it. So to summarize this whole journey for you listening, good information architecture is so much more than just designing a pretty user interface.
Much more.
By utilizing those 7 NISO concepts, things, materials, properties, measures, activities, disciplines, and events, you create a rigorous multidimensional blueprint for your data. But the real magic, the thing that actually drives revenue, happens when you understand the extrinsic context.
It is recognizing that a thermos is never just a stainless steel container. It is a camping survival tool or an office status symbol, depending entirely on the user's journey.
Exactly. When you organize your site around how humans actually think and shop, you drastically reduce their cognitive load. You feed the search algorithms exactly the semantic clarity and vector math they crave. And most importantly, you stop that invisible loss of revenue. You transform your website from a chaotic digital warehouse into a highly tuned sales machine.
This raises an important and honestly somewhat provocative question for us to think about as we move forward into the next era of the web.
Oh, what's that?
Well, the author noted that without extrinsic organization, without mapping products to human desire, an e-commerce site is just a warehouse. It relies entirely on the human's desire to bridge the gap and make the purchase. But we are rapidly moving into a future where AI agents and large language models might start doing our shopping for us.
Oh, wow. Yeah, like delegating my weekly shopping list to an AI assistant.
Exactly. If an AI bot is navigating the digital supermarket for you, will that bot care more about the intrinsic cold, hard facts of the materials and measurements? Or will we have to train these algorithms to deeply understand the nuanced, extrinsic, lifestyle-driven desires of humans?
That is wild to think about.
Like, if a bat is buying my thermos, does it know I want to look cool and productive at the office, or is it just optimizing the vector math for maximum vacuum seal efficiency?
That is an incredible thought to leave on. Will our digital architecture need to evolve all over again to sell directly to the bots? Or will the bots learn to desire and shop just like humans? We'll have to wait and see.
Yeah, it's going to be fascinating.
Truly. Thank you so much for joining us on this deep dive. Next time you find yourself frustrated on a messy website, unable to find what you're looking for, just remember, you aren't the problem. The architecture is. And somewhere in the background, there is a multidimensional vector graph crying out for just a little bit of order.